Okay, I think we'll get started. So good morning, everyone, and welcome to today's webinar on building a data stack for the age of AI. We're going to take a look at what it takes to build an effective data stack for your AI ambitions and focus in on how it differs from a typical modern data stack that we've been talking about for many years at Biztory, and I'm sure that you've come into contact with over the years as well. Before I get into the content, I noticed that there's a lag in my video connection here. So what I'm going to do is introduce myself on the next slide, and then what I'll probably do is cut my video so it's audio only as we walk through the deck, and I'll come back again at the end of the session as we sign off. So thanks for your patience on that one. So great to meet you all. My name is Lawrence Fox. I've got the privilege of leading Biztory's UK operation. For those of you that aren't aware, Biztory are a EMEA-wide organization. We're a modern data consultancy that specializes in accelerating our clients' AI and data maturity. And as I said, I have the privilege of leading Biztory's UK team as country manager. So as I said, I'm going to cut my video so that this connection runs smoothly, and I'll come back at the end as we've gone through the webinar content. So bear with me 1 second. Okay, super. So the one thing I wanted to start on particularly as we get into this webinar was a quote I heard at a Salesforce FY27 kickoff meeting. It really resonated with me at the time, and it still resonates with me today, particularly as we started building content for this webinar. And it was this idea that if 2025 was the year of the AI pilot, I'm sure you all felt it. The pilots popping up left, right, and center as people started embracing the accessibility of all this AI tooling. So if 2025 was the year of the AI pilot, then 2026 really needs to be the year that we see these projects starting to hit the P&L, starting to hit the bottom line. And so it's really got to be meaningful now in our advancements with AI tooling, because a failure to have these projects starting to impact the business in a meaningful way, I think could mean that we as businesses start losing our competitive edge against our competitors. And it could mean that, for example, exec teams, board members start losing patience either in your teams and your deployments, or faith more generally that AI can come in and be materially delivered at scale in your organization. So I think this year is going to be a really consequential year for AI solutions and their deployment, which is why hopefully I think this webinar is going to be really timely. Because this is what we've started to see. I could certainly point to it in our own organization and many of the clients that we speak to. This concept of a AI POC graveyard, with so many pilots being started in 2025 and so many failing, we have created this kind of concept of a graveyard where AI initiatives are failing, they're failing to reach production and are being killed off or abandoned. And I read a stat in a Gartner paper that said that in 2025, over 80% of AI pilots are failing to reach production, which feels in line with what we're seeing at our clients. And we see those failures for a whole host of reasons. I've just pulled out a few here on the tombstones. The one I'll lead with is a definition disconnect. So models, AI models, or large language models, lacking the business common sense to interpret your data according to the specific logic of your business. And that's something we're going to really focus in on in today's session. There's an operational gap. So experimental code of your POC, your sandbox environment, hitting the wall of real world scale and complex business operations. A business is so nuanced and so complex, and much more so than often our POCs allow for. And so they really hit that operational wall. There's often a governance void, so a lack of architectural guardrails that can turn AI potential into security and privacy risks. So that could put at risk your compliance with regulations such as GDPR. And there's an idea of a garbage multiplier where messy foundations in your data and invisible data flaws that maybe you haven't seen become really, really exposed and magnified at scale, and at the scale that AI can work at. And that can really undermine not only the success of your pilots, but also the operational cost of them. And it really sinks the ROI of every AI response and interaction. Because models themselves are exceptionally smart. So the models we're using, whether it's OpenAI, Anthropic, Google, or any other provider that you could think of, they're all incredibly smart, no matter what model you're using. But the data that you have is silent, which means that the model on its own struggles to work with, understand, and interpret your business data. The data can't talk to the model to explain where to go, how to interpret it, and how to work with other elements of the system. So we have a gap that's opened up, a gap between your business estate, the data in your business estate, so on the left-hand side of the slide here, and the AI solutions, the point solutions that you're trying to bring on the right-hand side. And this gap can exist no matter how sophisticated and how elaborate your data stack is. So even if you've invested a lot of time, effort, money into the right tooling, the right technologies, the right workflows to set up your data stack, these gaps can still exist. Because what these AI solutions need in order to be fit and cleared for production and delivering scale and delivering efficiently is a context bridge that works between the two sides. So a bridge that allows data to move seamlessly between the two states, so your business data estate and your AI solution. And for the AI model to also understand the rules of engagement with your data, what it should and shouldn't be doing, how it should work with your data, and where is out of scope. And the one thing that we're really going to focus on today is this top one in the green there, which is a semantic layer that gives the model information on how you can work fluently with your business data in these AI solutions. Because often what we've seen is when these pilots are failing, people think that it's because they haven't worked with enough data, that by somehow increasing the sample that this pilot solution is working off will improve the results. Maybe some more history, maybe a wider set of categories. They think that let's push more in and see if the model can suddenly grasp what it is that you're trying to do. But that is actually not the answer, particularly when LLMs are optimized for context and not raw volume. So simply dumping more data into the solution or into a database or an LLM can actually create more noise and not more intelligence. And it's the intelligence that we're really trying to train for here. So again, we see lots of different things happen, but just calling out a few of them. Toxicity of scale. So unstructured data without a semantic map can confuse the model. It doesn't know what it's looking at, how it interacts with each other, and where to go. There's a hallucination multiplier where more noise, so more data that you've thrown at it, actually just increases the probability that AI will start inventing facts to fill in the semantic gaps and the context gaps that it's missing. And all of those can contribute to a rising operational cost. So scaling, in particular volume, without the context increases compute costs, token costs, without actually improving the quality. So you get a sort of lesser quality of output, but an increase in operational costs. And ultimately, you're going to abandon because it's not delivering any sort of ROI, and the business isn't seeing the return on the investment, and therefore the project will fail. So for the remainder of the webinar, we're going to take a closer look at how we effectively bridge that gap that we spoke about, the business data estate and the AI solutions. And so we've called it here the water cooler effect, the language gap. Because I think language is the right word here. Because one of the common use cases we're seeing with AI in the analytics space, I'm sure many of you have seen this as well, is the desire to be able to hold conversations with your data, or your colleagues hold conversations with the data. So this is kind of principally called conversational analytics. You might have heard that term, it's a bit of a buzzword. Conversational analytics, where the AI can talk to you in the same way that you would with a colleague around a proverbial water cooler in your business. But in order for conversational analytics to properly work, there needs to be a fluency in the conversation. The AI needs to speak your language and needs to, and I'm not just talking about, English or whatever your native tongue here is. It's really all the nuances in your language that allows for that fluency. Because you can't just point an LLM at your data and expect it to work fluently with it and with the fluency of language, no matter how smart the model. So you need to be able to give it the fluency in order for it to be able to work with you and your team and your business. Because the model won't simply interpret the question on its own because it's missing all sorts of context. So this question on screen here, how did our online sales perform last quarter? That's for us, I think, a relatively simple question, but actually it's a really nuanced question. Before I kind of jump into that nuance though, first of all, the agent or the AI solution is missing the context of which tables it should be using to create the answer. So how do I find the right data that can ask this question? Unless you tell it, it's not gonna know. And so it'll often just guess. It'll just try and generate an answer for you and lead to incorrect answers. And secondly, as I said, it's missing that ability to understand all of the nuance in the language that you've used. So if we break down this really simple question and look at the nuance in a bit more detail, you'll see what I mean. So in this example, hour, what does hour actually mean here? Is it unique to the user? Is it a department? Is it a store? Is it a region? Is it the company as a whole? What does hour mean? When the question mentions online, what does online constitute? What does an online sale constitute? Does that include store pickups? Does it include mobile app? Again, you need to tell it. Does sales include returns, cancellations? Does it include the discount that you've given to the customer? And how should the model interpret your business calendar? Does your business work on a calendar year? Does it work on a tax year? Have you got something a little bit more custom? And many of the clients that we work for actually have kind of quite custom business years. So you need to, again, tell the model, tell the point solution exactly what you mean by last quarter. So all of it needs to be properly documented in order to get the results that you would expect when asking this simple question. Because if the model doesn't have the ability to understand the nuance, it runs the risk of just becoming a hallucination engine, where because it's missing the semantic context of your questions and all of that nuance from the previous slide, it's going to be forced to just guess. Most AIs are probabilistic, and so they will endeavor to return an answer in any case. What they'll do is essentially pick the most probable right answer rather than just say, I don't know. And that can lead to hallucinations, and in turn, basically a loss of faith in the whole system, and again, abandonment of the POC and the pilot. So in this example, specifically on screen here, you've got a book date and you've got a recognized date. So which of those, the book date or the recognized date, should be used when talking about actual revenue and the revenue you're taking? Again, the AI is not going to know unless you tell it. And it may assume, without that information, that these things are the same. It may assume that they're interchangeable. So every time you ask this question, it's going to give you inconsistent answers, which is obviously not what we want to get to. So it's absolutely integral that any AI and agentic solutions speak the same language as you and your business, with all of the nuance attached. Otherwise, they're never going to be able to join you around this water cooler, as we see on screen here. There's an agent that's joined you and your colleagues around the water cooler to partake in those business conversations. And the way we think about training the model on your language and the business data that you use and own is with a semantic layer. So now that we've kind of introduced that as a concept, what actually is the semantic layer and how does it bridge the gap between your AI and your business data? Well, the semantic layer is essentially a language map for AI. It's no longer just about BI reports. It's the definitive translation engine that maps against your messy data. That means your LLM can navigate it properly. So the semantic layer can act as a translator between structured query language, so as SQL, and plain English. So in this example here, user_ID in SQL becomes active customer, for example, in English. So it can make that translation for you, or you can define that translation. It can be a contextualizer that allows you to define that gross sales, for example, is X VAT, X VAT, exclusive of VAT. And also maybe that it excludes those testing accounts and that dummy data that you've run through the system to try and test it. And it can also act as a gatekeeper. So this idea that the model will only use validated and really well-governed versions and definitions of the truth. So as we're moving through this concept, we're starting to build for the fluency that we want to see in the solution. So in that semantic layer, we can properly define the key business definitions that you use in your organization and how you talk about the business, with your colleagues. So the synonyms you might use for sales or revenue. Is it cash? Is it income? Is it revenue? Is it sales? How do you typically talk about that concept? And the how and the what between or behind every single data point, really kind of driving all of the ways and the nuance with which you talk about those data points. You'll also be able to define the entity relationships of the data in your underlying tables and establish essentially like a map of how the data should be navigated. For example, how a customer table might map to a product table or an order table, and how you can build a data model that can work with those three tables in the way to give you the right result. And in here, you can also start determining the guardrails for that data that we spoke about. So enforcing definitions, enforcing policies, and in particular, rules of engagement. So that AI is prevented from hallucinating, going off on tangents, going off script, going out of scope. And you can keep it really on those sort of train tracks, if you want, of really well-defined, well-governed solutions. So again, just going a layer deeper then, what are the core components that exist within a semantic layer and how's it made up? Sometimes the language that we use around these concepts differ maybe from tool to tool, but essentially the concepts remain the same. And traditionally, the the semantic layer has these core components to it, which is data objects. So if we start on that left-hand side, data objects, these represent the data entities that you're going to use in your project. So that could be a data table. It could be a view, for example, in your database, or it could be a file repository, for example. So those are data objects. Then you've got this concept of a data model. So that, again, defines the relationship, the hierarchies, and the connections between those objects. So think about how tables typically join together, a left join, an inner join, a right join. You're defining that data model in the semantic layer. It'll also have the calculated fields and metrics that you've started to build out and work up on top of your data. So think about, for example, profit or profit margin calculations. You might actually not have that baked into the raw data. You'll likely have something like a cost of goods sold, and you'll have maybe a revenue line. And in this fields and metrics, you can then use those data points to define and to calculate a profit margin calculation. And that definition of that calculation is going to live again in the semantic layer. So you've got that single source of how that calculation is made. And then the final one I've got here is what's often referred to as preferences or business preferences. And this is a space, it's really crucial, a space in which the user can define all of the business preferences that you have. So the rules and the context for interacting with the data and how it should be used, and the guardrails to keep it within the defined boundaries of the operation. So as we've kind of moved through some of this content, we've identified the gap. We've spoken about how a semantic layer is the solution to that gap, and we've spoken a bit about the concepts. So the next stage is to think about actually where do you put that semantic layer in order for it to effectively plug that gap between your data estate and your AI solution. So that's what we're going to take a look at now. And I guess the thing I wanted to call out here on this slide was that semantic layers are not a new concept. They've actually been around in BI for a number of years now. In particular, Looker came to market and used that as its principal USP, or one of its principal USPs when it first launched, a governed layer in which to define business logic. So semantic layers have been around in BI for a long time now, but they're no longer defined to just BI solutions, right? But it is still true that semantic layers can exist within your BI tooling, and they can sit within each respective BI tool that you might use. And that's fine. At least there is one. But I'd say what this solution opens you up to, particularly if you're using multiple BI solutions, is it can open yourselves up to diverging versions of the truth. One number in one solution differing from a number in another. And those semantic layers, if they're not kept in sync and well managed, are going to start diverging, and that's where you're going to introduce that divergence. Because as a Databricks rather paper introduced, was often the biggest risk isn't a wrong number. It's actually a system where the right number depends on where you're asking the question. Because ultimately, if you're introducing that uncertainty, that can fundamentally undermine the confidence the business has in your whole data ecosystem. And I think it can run the risk of forcing a return to acting purely on gut and not on data, and not on a data-driven organization that we're trying to help people on a journey towards. This kind of point semantic layer solution is also, I think it's also not ideal in that as you bring in a AI or agentic solution, they're going to have no semantic layer to reference. And so another effect is that you need to keep recreating semantic layers for every point solution that you build. And so again, there's a lot of overhead, a lot of management of each of those semantic layers. And again, you run the risk of divergence. So it's good, but maybe it's not best. Far better would be to have a semantic layer that runs across all the platforms in which data is being surfaced and interacted with. So there are standalone tools on the market. I think DBT would be an example here that can create these semantic layers for you to act as like an intermediary layer between the data at rest and your point BI AI solutions. And that's great because it can create a single source of the truth and eliminate some of the risk of divergence that we spoke about in differing numbers. However, the issue is, I guess here, why this isn't maybe the best is there's this idea coming forward that do you really want your truth layer to be divorced from where your data is warehoused, where your data is managed and centralized? Does that distance to the truth between data at rest and your truth layer or semantic layer, does that actually matter? And does that run the risk of any issues down the line? Perhaps the best, and according to Databricks, a Databricks paper that I referenced before, it's increasingly regarded that this is the best-in-class solution, and that is to have a well-governed source of the truth right there along with your consolidated data, i.e. in your data platform. So that would create a one-stop shop for your data, your documentation, and the language with which you want any solutions to work with your data. But often, as the saying goes, beggars can't be choosers. And so any semantic layer, I think, is going to be a positive step towards enabling AI pilots and initiatives to have a greater chance of success. So with that semantic layer now defined and articulated, it's really well placed to now bridge the context gap between your data on that left-hand side and your AI models and agentic solutions that you've been trialing and so excited about. And it can enable the effective journey of data between the two and the fluency to move between the two. So incredibly crucial part of an AI data stack. So this is a diagram. Many of you will probably have come across things like this and might be familiar with this sort of thing. This is how we typically view a data stack for AI. And in its current form, as you see on screen, it probably doesn't differ too much from just a modern data stack, where we have on the left-hand side your source systems, so where you're generating that data, where you're getting that data from, those data inputs. Then we have in the middle here this concept of where your data is being centralized and where you're bringing all of your data assets. So a data warehouse, a data lake, and all of the pipelines, all of the plumbing, which is running to and from that centralized data. So with the ETL, ELT, maybe a reverse ETL if you're pushing data back into source systems. So that's that middle component. And then jumping over to the far right-hand side are these often BI solutions, right? On this right-hand side. So maybe a Tableau, maybe a Power BI, whatever it is that you're using on the right-hand side. The introduction of AI and AI tooling has brought in this piece here just before those BI solutions. So it's where you're bringing in your models, your LLMs, maybe an MCP solution. But there's one thing missing on here, which I would argue turns this from a data stack, a simple kind of cloud architected data stack, to one that is fit and ready for AI, and that is the semantic layer. I think absolutely critical and crucial in enabling an AI data stack. So that's what we've focused on today, and I think that's, as I said, the real differentiator here, which is why I've kind of focused my efforts on that piece. Because if we get this right, and as we introduce semantic layers and effective semantic layers, this is where we're introducing this new paradigm shift that many of us will have heard about at conferences and at other talks and other webinars such as these. So we're moving from this old state, this passive reporting paradigm where a user has maybe a gut feel that something's up and they make a request to a data team who are going to generate a report. Maybe there's a dashboard that they can self-serve from, and all of that's great. But we can start moving with a semantic layer to this new world of this right-hand side, where a semantic layer is now enabled and facilitated to have this sort of proactive and autonomous route with your data. And it can maybe notice a trend, it can understand the next best steps, and it can potentially go away and act on that step if you've allowed for that and make it a reality. And I think it's that state which is going to be a real game changer, a bold new frontier in BI. And that's, I think, the state that many of our many of our board members are getting really excited by and sold to about. But often people aren't talking about the work, particularly in the semantic layer, that needs to happen in order to enable that journey and that paradigm shift. So now that we've spoken about the semantic layer, we know what it is, we know how it's going to facilitate your journey and maybe those pilots moving to production. How do we get started? I think the thing I'd say is that people shouldn't be daunted by starting on these semantic layers. Please don't feel like this is out of your expertise, out of your ability to go and start executing. Because wherever you choose to build your semantic layer, there are an abundance of options to help you get started. So indeed, many of them actually have AI solutions within them to help you start defining things. So maybe if we take that profit margin calculation before, instead of you naturally knowing how to calculate profit, maybe you just want to ask the question or define what it is that you're trying to do in the solution, and the AI is going to go away and take a best guess at how you would typically work up a profit margin calculation. So it can help you give you a jump start and give you an easy leg up. There are also many out-of-the-box sort of pre-packaged models and templates for common business domains. So maybe in HR, for example, there might be a turnover rate of employees. So common business domains that have kind of shared terminology, shared calculations that are fairly generic. Often they're ready kind of out of the box, and so you can deploy very, very quickly if you want to use those templates, and then you can allow for more bespoke tailoring from that point onwards. So I think with that, you're ready to get started building your data stack for AI. You can really start having a go at the semantic layer and really facilitating this data stack for AI, and hopefully give your pilots and your AI POCs a real fighting chance of making it to production. And hopefully we can start collectively bringing down that 80% failure rate to something that feels more progressive. So that was the content for today's session. I really wanted to focus in on that semantic layer because many of the other concepts have been true and consistent for some time now. So I think that was the differentiator. And I love talking about semantic layers, and we at Biztory love talking further to our clients and to potential customers about their data challenges, their AI challenges. So I've got this QR code on screen that I'll hold for a second. We're absolutely on hand to help. We're on hand to talk further about these concepts and help you on your journey to data and AI maturity. So do feel free to take a screenshot of that QR code. That's going to direct you to our website, and on there's multiple resources, there's white papers, there's lots of things on there for you to go and have a look and indeed some more information about Biztory, and we'd be delighted to help you and talk to you further about this. So it's also got links to contact forms. So if you are interested in following up with Biztory, you can do so through that QR code. And with that brings our webinar to an end. And all that's left for me to say then is, and I'm going to bring my video back up. So apologies, I haven't been on screen. Thank you very much for joining me. I've really enjoyed walking you through building a data stack for AI. I've been Lawrence Fox, and as I said, I work for Biztory, a strategic modern data consultancy. So thank you for joining me. Thank you for joining Biztory, and we'll end the session there. Thank you very much for joining. Have a great rest of your day.